Welcome all, this is Matts Mapping and GIS. Today I'll provide you another project I've been working on. This is a solar farm planning tool. This tool will assist the spatial positioning of the solar panel array and panel. The analyst will have control of many elements, including the setting of multiple bearing aspects, the selection of solar panel product, the length of panel array, separation of each row and separation of each section. The output geometry analysis will describe the total estimated power output, the total count of placed solar panels, the total cost, the cost per megawatt output, and the total used and unused area. The analyst or planner can create feature areas that will be used as an input for the planning tool. Within the attribution table, the analyst and planner can provide key values. These values will be implemented in the process and output. With some quick input of tool elements, this tool can be underway. The geoprocessing output will provide the solar panel row and panel position. Zooming in, I'll provide the project area, the usable perimeter area, the solar panel individual rows, and the solar panel individual panels. I'll now go into how this tool functions, its design options, and the planning benefits. Here I've selected the feature input. At the bottom of the screen you can see the attribute information that's inputted. Just like the aerodrome planning tool, I've enabled presets. This allows the selection of different solar panel products. The name of the product, the expected watt output converted to megawatts, the cost of each panel, the size of each panel, and this is a text string that will be written to the output to assist communicating of what analysis has been conducted. For this explanation, I've just drawn out a simple square area. For this tool, I've created an internal buffer process. This is to cater for an offset from the perimeter boundary or fence line, allowing utilities, vehicles, or other access. I've also written the analysis presets and calculated information to the internal perimeter feature. This information is hugely beneficial when creating a map series. Another function of this tool that I'm keen to show off is the ability to set a datum point. This allows the planner to designate a specific point where the pattern will start. Here I've moved the datum point to just off the left-hand edge of the area. I've also adjusted the bearings so that they're all 45 degrees. The datum point can also be placed off the site location. And as well within this example, I've changed the bearing degree angles, with the overarching pattern being 45 degrees, while the row and panel bearing are set at 10 degrees. Here we have a summary and comparison map. This displays the detail of the separate planning options. The key differences between these two patterns are that the one on the left has less rows, but it has more solar panels, acknowledging that if we implemented the point datum to start right at the left-hand corner and shift all the rows up, then we would likely be able to fit a full set of rows at the space at the bottom or the top. Then this count of rows would be larger. On the right-hand side, with both rotations, there's a larger gap forming between each of the sections. We could measure this section and reduce that gap. And that's the great benefit of this tool set, is that these changes can be very quick. Here I've rerun the analysis, this time keeping the same pattern, but changing the solar panel product. Below here is the solar panel information. Apologies if this is difficult to read on the YouTube video. The power output for the product on the right is higher, and the cost is lower. So what this means is we have higher potential megawatt output, lower cost per megawatt, and lower total cost. Again, this is to highlight the effectiveness of the tool. Before closing off, I'll show one more demonstration. Here I've attempted to match my planning output to a functioning solar farm. Here I'm showing I've digitized and captured the bounding area of each significant section, removing the areas not used for the solar panels. I've also placed the datum point at the bottom left-hand corner of each section. Here I'm displaying the attribute information used for this input. Pay particular note to the pattern bearing. This, the row length, the row separation, and the section separation was all measured by eye from this imagery. And this is the output. I want to highlight that my output is not in sync. It doesn't line up perfectly against the imagery. I believe this is due to the lack of precision I have with the imagery I'm currently using. I believe if I had surveyed coordinates of where these sections start and end, and the exact measurements of the row length and the row separation, then my planning output could perfectly match the real-world solar farm. This toolset has numerous avenues for further developments, like incorporating solar radiation and shadow data, peak sun hours and seasonal data. I can also include more accurate cost planning, including installation costs, periodic maintenance, through the panel's entire life cycle. This analysis could be combined to estimate the total yearly power output and costs. I'd also look into the demand estimation, considering city and processing facility power requirements. If you have any questions or are interested to discuss this further, please leave a comment or reach out to me. This has been Matts Mapping and GIS. Thank you and goodbye.